This is the second video where I'll show you how to predict the products, write phases, and balance the equation of these precipitation reactions. Now I'll also show you how to write the complete and net ionic equations. So in this example we have K2S, this is potassium sulfide. AQ stands for aqueous. The second reactant is a solution of nickel nitrate. Now, nickel is a transition metal, and so remember this is called nickel 2 nitrate. How do we know it's nickel 2 nitrate? Remember from chapter 2, with the transition metals, we need to know what the charge is. So nickel is one of those transition metals. I don't know the charge, but I do know the charge of the nitrate. Nitrate is always a -1. There are two nitrates. That means in order for those charges to balance, the nickel has to be a +2. So that's how I know it's nickel 2 nitrate. This is also aqueous, so that's why I said that this was a solution, because that's what aqueous means. Okay, so let's identify the ions that are present in solution. Potassium sulfide has potassium ions and sulfide ions. The nickel nitrate solution has nickel ions, and it also has nitrate ions. And so remember, when we have these solutions mix, what typically happens is we get this double displacement process. Easy thing to remember is let's go ahead and swap those ions. So those anions, we'll go ahead and swap them. So on the product side of the yield sign, we want to write those species. So we'll write a product with potassium, but instead of the sulfide, we'll write the nitrate ion, and then the second product we'll write the nickel, but instead of the nitrate we'll write the sulfide. So now that we identify the ions present on the product side, let's go ahead and write those formulas. The formula for the first product is K plus NO3. We want to write that formula where the charges balance +1, -1, so we just need one of each. KNO3. Our second species, nickel 2 plus, sulfide 2 minus, we want to write a formula where these charges will balance 2 plus, 2 minus, so we just need one of each. So those are the two products. Now let's write the phases. You got to go back to the solubility rules and you'll see that the potassium nitrate is soluble. Soluble means aqueous, that it dissolves in solution. The nickel sulfide, you'll notice nickel is soluble with those cations of group 1, ammonium, and a couple of other ions, but nickel is not one of those ions. And so sulfide is going to be insoluble when it's complexed with the nickel. So insoluble means it doesn't dissolve. So we're going to write an S to represent solid. Okay. At this point, we've written the products with the formulas and we've written the phases. Let's balance the equation. We need a balanced equation in order to do stoichiometry. You notice that the equation is not balanced. So just to balance by inspection, inspection just means look at it. There's 2 potassium. Over here there's 1 potassium. There's 2 nitrate. Over here there's 1 nitrate. So we'll balance by writing a 2 in front of the potassium nitrate. And so what we've done here is write down the formula equation. Okay. So now let's move over to the complete ionic equation. Now, if you remember the first video, I go into detail on how to write the complete ionic equation. So I'll just summarize that here. Every time we see an aqueous, we see 3 of them here, what we want to do is separate those species, those ions, so that we can have a better representation of what's going on in solution. So for example, right here, K2S. When this thing dissolves in solution, watch very carefully. 2 potassium ions will dissociate for every 1 unit of compound. So let's think in terms of moles. For every 1 mole of species, there are 2 moles of the potassium ion. So in the complete ionic equation, I'll write 2 K plus aqueous. For every 1 mole of the potassium sulfide that dissociates, there's 1 mole of the sulfide that dissociates. Look at the nickel nitrate. For every 1 mole of nickel nitrate, there are 1 mole of nickel that dissociates, 2 moles of nitrate that dissociate. Okay, let's look at the product side. On the product side, notice how there's 2 moles of potassium nitrate aqueous. So when 2 moles of potassium nitrate aqueous dissociate in solution, there are 2 times 1, 2 moles of potassium, and 2 times 1 nitrate, so 2 nitrates that dissociate. Whoops. There you go. And finally, remember what we did last time. Whenever there's a solid, remember that solid is being produced. That solid is a solid compound after the solutions have been mixed. So the nickel and the sulfide are not in solution anymore, but rather they're forming this solid compound. So in the complete ionic equation, we're going to leave the nickel sulfide together. And that's the complete ionic equation. What's the net ionic equation? You think of this equation like a math equation. You look on either side, whatever appears on both sides, they'll cancel out. And the net is everything that's left over. You'll notice there's 2 moles of potassium at the beginning. After the solutions have mixed, there are still 2 moles of potassium. There's 2 moles of nitrate at the beginning. After the solutions have been mixed, there's still 2 moles of nitrate in the aqueous phase. So these ions that cancel out are called spectator ions. K plus and nitrate are spectator ions. They don't do anything. Now, look at the nickel and the sulfide. Nickel and sulfide are ions in solution to begin with, but at the end, they form a complex. They're not aqueous anymore. There's nothing to cancel here. So our net ionic equation I'll write the cation first, because that's what we're used to, writing the cation first. So our net ionic equation is nickel reacting with sulfide to yield nickel sulfide. Nickel 2 sulfide, sorry.